let's talk about types of data. We can go through this more quickly because of the fact that you've at least seen the words. We'll clear up some misconceptions maybe, but you've seen this. The subject of statistics is largely about using sample data to make inferences or generalizations about an entire population. There's a lot of vocabulary in the next few sections. We've got to learn the language of statistics before we can start talking in statistics. A parameter is a numerical measurement describing some characteristic of a population. Now, we had already said a population is an entire group defined somehow like the population of all cars or the population of adults in the U.S. That's talking about all the adults in the U.S., so that is a population. If I tell you some characteristic of that population, if I say 70% of adults in the U.S. believe blah, 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 then that 70% is a parameter because it comes from the entire population. Whereas a statistic only comes from a sample. It's very difficult to get a parameter from a large population. You're not going to be able to ask everybody your question or measure all the widgets being made on a given day. So you're going to take a sample, and from that sample, you're going to find a statistic. You know what makes this easy to keep straight is population and parameter both start with P. That's kind of handy. And sample and statistic both start with S. That'll help you remember that a parameter comes from a population, a statistic comes from a sample. Determine whether the given value is a statistic or a parameter. Among the senators in the current Congress, 44% are Democrats. To know whether that 44% is a statistic or a parameter, you need to ask yourself, are the senators in the current Congress, is that talking about all the senators in the current Congress or part of the senators in the current Congress? Is that a population or a sample? It doesn't say anything about a sample of senators was taken. It sounds like that 44% is all the senators in the current Congress. And if that's a population, then the 44% is a what? A statistic or a parameter? It's a parameter. To mean sample, it's hard to imply sample without using the word sample. I could say a few were taken, and that means sample, but unless I say something that indicates that I'm taking a few out of a large group, then it's a population. If I do use the word sample or somehow imply that it's just some of the whole group, then it's a sample. In New York City, there are 3,250 walk buttons that pedestrians can press at traffic intersections. It was found that 77% of these buttons don't work. Was there a sample taken, or is that talking about all 3,250 buttons? It doesn't say anything about sample. It sounds like somebody went around and pressed all 3,250 buttons and found out that 77% of them don't work. Didn't say anything about a sample. So if that 3,250 is the population, that 77% is what? A parameter. Good. The average atomic weight of all elements in the periodic table is 134.355 unified atomic mass units. Is that a population or a sample? It says all elements, so it's talking about all the elements on the periodic table, which makes the 134.355 a what? A parameter. All three of the first ones were parameters. The author randomly selected 35 movies and found that the amount of money they grossed from ticket sales average was 123.7 million. Were all the movies surveyed? Nope, just a sample of them, which makes the 123.7 a what? Statistic. All right, you got it. There are two main categories of data. And I use my hands a whole lot because I'm trying to leave a visual image seared on your brain. And it's not this, it's this. There's two main categories, quantitative and qualitative. Quantitative data consists of numbers representing counts or measurements. Very importantly, it has to be numbers. And numbers that you could count or that you could measure by weighing or holding up a yardstick or using a time piece. Qualitative data is also known as categorical data. It's just names or labels which represent categories. The genders of professional athletes. You fall in the category male or female. Those aren't numbers. That's not quantitative data. That's qualitative data. Shirt numbers on professional uniforms, those are numbers. But are they really numbers that represent a count of anything or a measure of anything? No, they just stand for the person's name. 35 is so-and-so, so-and-so. That's just a name. So even though it's a number, it's qualitative or categorical data because it's not a count or measurement of something. All right, so that's the two biggies, categorical or qualitative, and then quantitative. We're going to talk about subtypes for the quantitative, different kinds of quantitative data, specifically discrete and continuous. Discrete data results when the number of possible values is either a finite number or a countable number, something you can count, like the number of eggs that a hen lays, or the number of people in this room, or anything you could count is a discrete data set. But a continuous data set results from infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, interruptions, or jumps. Now, I could copy that straight down out of the book without reading any examples. I could have something on my study guide. But does that really make sense? Probably not unless you read the examples under it. And so on your study guide, in addition to that definition, which may or may not make sense to you, put something that'll help it make sense to you, like the amount of milk that a cow gives a day. A cow doesn't have to just give 2 gallons or 3 gallons. It could be 2.57 gallons. Or if you had a better scale, it could be 2.579381 gallons. That's a continuous scale, and you can be infinitely precise if you had an infinitely precise measuring device. You can't count the number of gallons of milk because you can count the number of whole gallons. But if I just say, how much milk did your cow give? You could give an infinitely precise number for that, and that's why that's continuous. Yes, ma'am. Doesn't have to be, and we'll see an example in just a minute. If that was all it was, then that's the definition. That's what would be there, just whole number. But wait till you see the example that's not a whole number and see if that answers your question. If not, we'll go right back to it. Miss Ashley? I don't want to say it like that because the same thing would apply to chickens and eggs. A cow could lay an egg. No, it couldn't. A chicken could lay 2 eggs one day and 3 eggs the next. It's not the changeability of that. It's the fact that there are a bazillion numbers on a number line between 2 and 3, right? 2.5, 2.58, 2.583712. That's continuous. So it's not, could be different on a given day because that same thing would apply to chickens and eggs, but it's the fact that it's being measured, not counted. I thought of one other thing that if you get this right in your English class, Miss Vaughn will come hug me. Do you know the difference between when to use the word few and when to use the word less? Fewer or less? They're actually not interchangeable. You use the word fewer for discrete data, things that can be counted. There are fewer people in the world who do blah, blah, blah now, because you can count numbers of people. But you don't say you shouldn't say, we do say, but you shouldn't say there are less people, because less is continuous. It's like less milk makes sense. You wouldn't say fewer milk, you would say less milk. So if it can be counted, it's discrete. If it can be measured to an infinite degree of precision, it's continuous. One other thing, and then Ms. Harley, I'll answer your question. The key word here is measurement. Continuous always comes from a measurement, something being weighed or measured with a yardstick, or why in the world can't I think of the word of the thing that you use to count how fast somebody goes at a race? No, the little... Oh, it's just like I'm going time clock. No, that's not it. Stopwatch. Stopwatch. That's it. I was trying to think of the words. I was trying to think of stopwatch and it just wasn't coming. So that's a measurement. In the Olympics, the finishing time for various races isn't given to the nearest whole second or even to the nearest tenth of a second. Those races can be so close that they measure them to the nearest thousandths of seconds maybe, and could even be more precise than that, because time is continuous. Miss Arlie, what was your question? No, that's rather like this question. Does discrete mean whole number? It's not whole number decimal. It's countable versus measurement. Let's see the examples, and if the examples don't clarify it, then we'll come back and beat on the definition some more. Yes.
How fast or how far you can.
Exactly. You can. You can measure it to any certain degree of precision anybody wants, but you can't count it because time is a continuous scale. Let's see the examples and see if this helps. Determine whether the given values are from a discrete or continuous data set. In the Literary Digest poll, Landon received 16,679,583 votes. Is that a count of something or a measure of something? Boy, y'all aren't good at multiple choice. I said count or measure, and y'all said discrete. Is it a count or a measurement? It's a count, which means it's discrete. Now you can use that word. It's discrete because it's a count. The volume of cola in a can of regular Coke is 12.3 ounces. Is that a count or a measurement? That's a measurement, which means it's continuous. If I had a better scale, it might actually be 12.5792 ounces. It's not the fact that there is a decimal or isn't a decimal. What matters is this is a measurement, not a count. When a woman is randomly selected and measured for blood pressure, the systolic blood pressure is found to be 61 millimeters of mercury. Is that a measurement or a count? I've had nurses fight over this one. We had a great mud fest one time. But this lets me make a good point. And you can call me a lot of things. You can call me mean and ugly and bad. Don't call me unfair. Don't call me unfair, or we're going to have to sit down and have a long talk about fairness. If I have a finite number of problems to accountable, a discrete number of choices in the problems that I can either put on the homework or the test, if I think a problem is debatable or requires some kind of knowledge that you may or not everybody's going to have, I'm going to put that problem on the homework, not the test. I try to pick the very most clear problems, and they're not going to feel clear to you, but they would if I showed you the unclear ones. I'm going to put, if the one is debatable, I'm going to use it as an example, or if I have to put it in the homework, I try my very best not to put on the test anything that an argument could be made for two of the answers, or you have to know something like about blood pressure. There's kind of a giveaway here. The fact that it said measured means this is a measurement. But the two nurses, actually I've had two nurses debate this every semester. I've had a nurse say, but you always report blood pressure to the nearest whole number. It's either 61 millimeters of mercury or it's 62 millimeters of mercury. It's never 61.57. Well, it's still a measurement. It may be always reported as a whole number. And here's where I don't know. I've never taken anybody's blood pressure. I've had it done. I've seen the needle, go somewhere and stop. That needle, even the very motion of the needle, it can't just stop here or here or here. It can stop anywhere in between. That's a continuous scale. The word measurement is the giveaway, but I wouldn't put that on a test because I feel like you almost have to know something about blood pressure to get that one. If you ever on the test feel like, hey, this answer's counted wrong, but I can make a good argument for it, I'll listen because I don't want you to call me unfair. It's not what you call me that matters. I don't want you to feel unfairly treated. So if you don't think a problem on the test is fair, tell me. I'm not going to hit you. I don't hit people anymore. Dean told me to stop. I'm kidding. If you think a problem is poorly worded or unfair, let me know. Either I can defend my answer or I will change your score. That's as fair as I know how to be, but you have to tell me if you feel that way about something. All right, so, boy, that was a lot of talking, and what's the answer here? Probably supposed to be continuous because that is a measurement of something on a continuous scale. What about pulse? Would that be discrete or continuous? Beats per second. If anybody has a half a heartbeat, let me know. I think your heart either beats or it doesn't beat, and you can count how many times it beats in a minute. So pulse is definitely discrete. Blood pressure, I think, is continuous. All right. Now, what about the I have $3.25 in my pocket? Is that a count or a measurement? So is it discrete, but it's not a whole number? It's still discrete because it's a count, and we can't be more precise than that. If we're talking about money, the highest degree of precision that we can give is what? To the nearest cent or penny. We don't have any smaller unit than that. So money is always a count, which is discrete. If you want to talk about how much the money weighs, that would be continuous. But just counting your money, that's discrete.